Here we have the MAF sensor connector photo from AllData. Over here we've got the MAF sensor back probe. The black lead is already connected to the ground. I've got the pink pin hooked up to the engine main relay fuse control, and the yellow pin is hooked up to the MAF sensor signal. So whenever we actually check the voltage on the yellow pin, which is the sensor signal, we get about 2.5 volts, which makes me think that it's actually 5 volt reference and that it's just averaging the two out. In just a second we're going to get a hertz reading just to double check. On the pink pin we get source voltage. So now I'm going to switch my DVOM to hertz, and on this, what I think is the sensor voltage, we get a hertz reading.
So here we have the AUT sensor back probed, and we have the airbox partially undone here with our heat gun. So we're going to try to see if we can heat this up, and we're going to get a change in the reading. So right now we're reading 1.95 in that range here. But as I take this heat gun, I'll put it on low at first, and I'll stick it underneath here. We can start to see that the heat is getting to the negative coefficient thermosphere, and as we gain more heat, it goes down. So now I'm going to switch to high, and we should see that number go down a lot quicker. And now, if I turn it all the way off, put the airbox back in its place, we should see it pause for a second, and then it's going to start increasing again. Just like that. So here we have our ECT plugged into some probes, and we got it hooked into our DVOM, and right now we're reading 10.66 kiloohms at about 70.3 degrees on here. So now we're gonna heat it up with the heat gun, and then we're gonna retake these readings, and we'll show you at what temperature and how many ohms that it's reading. So after leaving the heat gun on it for about 3 minutes, we're reading about 1.56 kiloohms, and then if we go here and test how hot it is, we're reading about 116 degrees on the ECT sensor. So as we heat it up, the resistance goes down, just like it should. And now, as we can see, the heat's coming off of it, and it's steadily climbing back up to what it was before.
Here we have the MAP sensor back probe. We were trying to get a voltage reading at it, but we didn't get a good one, and so we thought maybe we should check hertz, and sure enough we got a hertz reading. So now we're going to introduce some propane into the intake, and as that enters the intake manifold and goes into the MAP, the engine's it's gonna load up the engine and cause it to be inefficient. So then we're gonna be able to see the hertz reading go down as I hit the propane a little bit. You can see it causes the hertz frequency to go way down with the extra propane in there.
Alright, so now we're working on the cobalt cutout that we have here, where we can control a lot of the things. So we're going to be looking for APP sensor readings. So we're going to see that for pin 1 we have the APP sensor signal 1, and then for pin 18 we have APP sensor signal 2. But we're just going to use number 1 here, so now we are going to turn this on and get that to run, and now we have our voltmeter here set up, and we have a pedal down here. So now I'm going to press on the pedal, and that RPM won't change, but we can see that when I slowly start to put pressure on the pedal, the voltage goes up and then it maxes. So that's its max right there, and then I can take it all the way off. But if I go all the way maxed, injectors turn off and it looks like we go into clear flood mode.